In this video, we're going to talk about Rolle's theorem and the mean value theorem. So we looked at the extreme value theorem in our last video, and that said that on a continuous function between some interval a to b, that you're going to have a maximum and a minimum value. And those values can occur at the endpoints, potentially. Rolle's theorem takes that same idea but tells us that there's got to be some maximum or minimum value between those two interval points from A to B and not just at the endpoints. And so we can prove that where we have there's at least one number C between A and B where f prime of C is going to give you 0. So that could be a maximum or a minimum point. Let's start off with this problem where we're asked to find the two intercepts of this quadratic and show that f prime of x is equal to 0 at some point between those two x-intercepts. So what I've done first is set our f of x equal to 0 to find the two x-intercepts. So that's going to be at 1, 0 and 2, 0. And next I'm looking to prove that some f prime of x is equal to 0 at somewhere between x equals 1 and x equals 2. So I first take my derivative, so f prime of x is 2x minus 3, I set that equal to 0, solve for x, and I get 3/2, which actually is in between 1 and 2. So that proves Rolle's theorem here. So our next example is using this function, f of x equals x to the fourth minus 2x squared, and let's find all the values of c on the interval between -2 and 2 on the x-axis such that the derivative of f prime at c, some value between -2 and 2, will equal 0. First thing I notice here is that when I plug in -2 and 2 into the original f of x, I result with a y equaling 8. So the next thing I'm going to do is find those c values between -2 and 2 that result in the derivative equaling 0. So I take the derivative, so f prime of x is equal to 4x cubed minus 4x. And so I can pull out a 4x, I've got x squared minus 1, going to set them both equal to 0. I can factor this guy. So I have 3 values for c, which is really just x, on the x-axis. So 0, positive, -1 are all values of c where f prime of c is going to equal 0. So now let's talk about the mean value theorem. So this thing says that if f is a continuous function that exists on a closed interval from a to b, and it's differentiable on that open interval from a to b, then there's going to exist some number c within that interval a and b such that this difference is going to exist. So you're going to take f of b minus f of a all over b minus a, which is a slope formula. And the mean here is representing the mean or average of the change of f on the interval from a to b. So that makes a lot of sense that it has to do with the slope as well. So at some point c, we have this tangent line that we can draw, and from a to b, it's also going to be parallel to the secant line, which is what the mean value theorem really gets at. And although we can use the mean value theorem to prove a lot of things, it's mostly used to prove different theorems and is kind of like a little tool that we use to further along whatever math we're trying to do. So let's try out this example where we have f of x is equal to 5 minus 4 over x, and let's find all the values c on the open interval from x equals 1 to x equals 4 such that we have our mean value theorem derived here. So the first thing I do here is figure out what this thing is equal to. So f of 4 is 4 and f of 1 is 1, and so that gives me 3 over 3 or 1. So next what I'm going to do is take the derivative of f of x and set it equal to 1 and see if I can't find some value there for x. So what I do is I'm actually going to rewrite f of x as 5 minus 4 times x to the -1. So I can just take the derivative there. So I get 4x to the -2 or 4 over x squared. I'm going to set that equal to 1 and I solve for x squared equals 4. So x is going to equal positive or -2, but it's only going to be positive 2 because I'm working with an interval that is positive. So -2 is not going to fit on that interval. So that means that all the values of c, so just x equals 2 or c equals 2, that is going to give you this definition of the mean value theorem right there. which essentially says that the slope of this tangent line is the same as the slope of the secant line from x equals 1 to x equals 4. And our last example here is a word problem, but it's a good one, in my opinion. So let's say that we have two stationary patrol cars equipped with radar that are 5 miles apart from one another on a highway. So a truck passes that first patrol car going 55 miles an hour. And then 4 minutes later, it's tracked by the second patrol car going 50 miles an hour. So we have to prove that the truck must have exceeded the speed limit, which is 55 miles an hour, at some point during those 4 minutes. So we're going to use the mean value theorem to do that. First thing I'm going to do is establish some things that I already know. So the truck is first clocked at time equals 0 hours. We're using hours because speed limit is usually in miles per hour. So we're going to start at t equals 0 hours, and then we're going to stop analyzing at t equals 4 minutes. And 4 over 60 parts of an hour is 4 minutes, so that's 1/15 of an hour. So that's why you see 1/15 instead of 4 from here on out. And something else we can consider is the function of s of t. So that I'm going to use to represent the distance traveled by the truck, which is in miles, of course. So it hasn't traveled anywhere, technically, at time equals 0, so that's 0 miles. And after 4 minutes, or 1/15 of an hour, it's traveled 5 miles, because that's how far apart those two patrol cars are. So the average velocity, which is the same as f prime of c in our mean value theorem, is the s of 1/15 minus the s of 0, so that's 5 minus 0, all over our time here, so that's 1/15 minus 0. So that gives me 5 times 15, and that's 17 miles an hour, the average velocity that this truck is going between these two patrol cars, which is way faster than the speed limit. So hopefully those cops can do some quick math and give this guy a ticket. All right, and that's going to do it for this video. Thanks for watching.